For the lesson today, we're going to look at exponential equations. Before I actually explain what exponential equation is, let's have a look at the index laws. Last couple of lessons, we have been looking at index laws. And I want you to recall what index laws are. And remember, for any rational indices, A and B must be positive numbers. All right? So recall the index law 1, 2, 3, 4, 5, negative index, 0 index. From there, what we're going to do is actually look at, using the index law we know, how we rewrite certain things. Let's think about the first bit. If 2 to the power of 2 times 2 to the power of 4 is actually 2 to the power of 2 plus 4, and therefore 2 to the power of 2 times 2 to the power of 4 is 2 to the power of 6. Right? So this time, what if we have 2 to the power of x times 2 to the power of 4? What do we do? Alright, can we solve for x? This time, what we do is we write this bit using the index law. We can rewrite 2 to the power of x times 2 to the power of 4 as 2 to the power of x plus 4. In this case, we can equate x plus 4 equals to 28. Alright? So therefore, when we write x plus 4 equals to 28, x is actually 24. See, rewriting this, x as 24, we have 2 to the power of 24 times 2 to the power of 4 equals to 2 to the power of 28. This time, how about this? How could we solve 2 to the power of x equals to 32? Alright, obviously, what we really need to do is actually write 32 in the form of 2 to the power of something. We know that 2 by 2 by 2 by 2 by 2 is 32. Therefore, 2 to the power of 5 is 32. Rewriting 2 to the x equals to 32 equals to 2 to the power of 5. We can therefore equate this to this. X equals to 5. Now, let's try a few more. I want you to pause the video for about a minute or so. Try to solve both 10 to the power of x equals to 10,000 and 5 to the x equals to 625. Let's pause the video for a while, approximately a minute. Hopefully you're ready and you've solved it. Let's see my solution compared to yours. Draw a line. This time, if we have 10 to the x equals to 10,000, we know 10,000 is actually 10 times 10 times 10 times 10, or 10 to the power of 4. Therefore, 10 to the x equals to 10 to the power of 4, x equals to 4. Alright? What about the next bit? We have 5 to the x equals to 625. Now, we know that 625 is actually 25 by 25. It is also 5 by 5 by 5 by 5, or 5 to the power of 4. Therefore, x is actually 4. So, in this case, we can conclude that if a to the power of x equals to a to the power of y, then x is actually equals to y. Note, a to the x equals to a to the power of y is actually the exponential equation. This is true for a greater than 0 and a is not equals to 1. The reason why a cannot be equals to 1 is because 1 to the power of anything is equals to 1. So therefore, we are not sure that x could be equals to y, because 1 to the power of 5 is actually 1 to the power of is 1. 1 to the power of 3 is 1. But 3 does not equals to 5. Therefore, a cannot be 1. Alright? And note that there's always only one solution. This time, what I want to do is try out and solve it for a fraction. I'll show you an example, then I want you to pause the video and work on example B and C. Alright, let's start off with A. 2 to the power of x equals 1 over 8. Now, from negative index law, you actually do know that a to the power of minus m is actually 1 over 8 to the power of m. Alright, let's rewrite 1 over 8. 1 over 8 is actually 1 over 2 to the power of 3. And since you know that a to the power of minus m is actually a to the m is 2 to the power of minus 3. Therefore, x in this case is minus 3. Alright, I now want you to pause the video for 1 minute. Try to work on B and C. Let's have a look at example B and C. 7 to the x equals 1 over 343. Now, we actually know that 343 is 7 to the power of 3. Alright? Therefore, we can rewrite 1 over 343 equals to 1 over 7 to the power of 3. And that actually equals 7 to the power of minus 3. That is based on the negative index law. So therefore, x is actually minus 3. What about the next one? 7 to the x equals to 1. Now, we know that from the zero index law, any number to the power of 0 is actually 1, except when a cannot be equal to 0. Therefore, we know that x in this case is actually 0. Now, let's try it out a few more. Different sort of examples. This time, you've got something like 16 to the power of x equals to 32. How are you actually going to do this? I'm going to show you one example, and then you're going to work out the other two. Alright, let's try this. 16 to the power of x equals to 32. Now, what we can do is to rewrite 16 and 32 in the form of 2 to the power of something. Let's have a look. 16 is actually 2 to the power of 4, right? And 32 is actually 2 to the power of 5. So therefore, rewriting 16 is 2 to the power of 4 to the power of x equals to 2 to the power of 5. Oops, that's x, not 6. So therefore, 4x equals to 5 and x equals to 5 over 4. Now, again, I want you to pause the video for 1 minute and work on B and C. I think that's quite enough time. Let's have a look at B and C. We can rewrite 81 as 3 to the power of 4 and 243 as 3 to the power of 5. Alright, you can see where this is leading to, because we are substituting 3 to the power of 4 as 81 to the power of x equals to 3 to the power of 5. Again, 4x equals to 5 using index law, x therefore equals to 5 over 4. How about this? 256 to the power of x equals to 32. We know that 256 is actually 2 to the power of 8, and 32 is actually 2 to the power of 5. So therefore, what we can do is to rewrite 2 to the power of 8 to the x equals to 32, or actually 2 to the power of 5. Therefore, 8x equals to 5, x equals to 5 over 8. So now, what we have been doing is solving for just x. Alright? This time we are solving for x, but instead of x alone, we actually have an expression with a constant. Let's see how we could solve this. I'm going to show you both examples. 3 to the power of 2x minus 1 equals to, you know that 81 is 3 to the power of 4. Therefore, 2x minus 1 equals to 4, 2x equals to 5, and x therefore equals to 5 over 2. The next one is just a little bit more complicated because it involves asserts. But you do actually know that assert square root of 6 is actually 6 to the power of half, correct? So therefore, we can rewrite the right hand side as 6 square, which is 36, times 6 to the power of half, which is 6, 2.5, or 6, 5 over 2. Alright? This time, let's rewrite the whole thing. 6 to the power of x minus 1 equals to 6 to the power of 5 over 2. So x minus 1 equals to 5 over 2. X equals to 1 plus 5 over 2, which is 7 over 2. That's it. This is how you solve it.